I wanted to make a separate video for surface tension and viscosity under lesson 3.1 for physical science, because we're going to do a mini lab the following day, the day after the lesson. So I wanted to go over in kind of layman's terms surface tension and viscosity, because a lot of times when you look it up, it's really going to be overly complicated. So surface tension is explained by kind of a water balloon, if you picture a water balloon. So surface tension is particles, particularly particles with high surface tension. It's a characteristic. Um, so particles or molecules that have high surface tension are going to go outwards, or basically just going to travel outwards. So think of it as water going outwards. It's the tendency of water to form a drop. So if you see like a drop of water on a leaf, right? When you drop water on something, it tends to form into a little ball because the particles are all going outwards equally in all directions. Simple surface tension. If a liquid has surface tension, it will turn into a ball when it drops in little droplets. Think of a water balloon, right? The way that the water fills is going to naturally take a circular shape. Now, obviously, the balloon is also a circle, but that's taking advantage of the surface tension um, for the shape, right? Because liquids don't have a defined shape. So surface tension would be making drops, as opposed to a liquid that doesn't have a very good surface tension, like gasoline. You'd see it flat on the floor. There's no drops. Even though it drops like a drop, when it hits the floor, it becomes flat. And you see it, with the iridescence, the little rainbow shapes or whatever, with gasoline, but you don't see little gasoline drops because, you see it pool together, but you don't see little drops because it doesn't have good surface tension or high surface tension. So if you think surface tension, it's water becoming little droplets. Whereas viscosity is a little bit easier to understand. Again, when you look up the definitions, it's going to have to do with bonding and like the attraction forces between bonds and different things like that. But really all it is think of honey. How when you go to pour water, it pours very easily. If I were to take this cap off and dump it on my computer, we'd have a problem, right? Very quickly. But if I take a spoonful of honey and try to flip it upside down, a lot of times it's just going to sit there for a little bit and then slowly go down, because the honey has a high viscosity. So that's kind of like dripping ability, right? So high viscosity means it's more glued together. It's like glue. It's viscosity is how slow it is. Okay, low viscosity would be water dripping quickly. So water is a good way, kind of a baseline to measure, because it has high surface tension compared to gasoline, and it has low viscosity when compared to honey.